Hello, Algebra 1 students. The purpose of this video is to give you detailed instructions on how to complete the activity for today. So we are continuing with our observations and taking note of the key features of quadratic functions before we start working with them. We began by graphing them and then looking at them and identifying parts. We did this first with paper and pencil. We also did a Delta Math assignment, and now we're back to a different view of a paper and pencil activity. There's no arithmetic, there's no math that you have to do here. You just have to graph. You just have to observe. And like I said, you just have to observe and take note. So the first thing that you see up here is I want you to write down the x-intercepts. Okay? We know that the x-intercepts are the places where your graph crosses the x-axis. So you are going to identify those places, and I want you to write them as an ordered pair. The reason I want you to write them as an ordered pair is to cement in your mind that at this place on the x-axis, on the coordinate plane, the value of your y-coordinate is 0. So my x-coordinate here is approximately -1/2. So that's what I wrote. And then my y-coordinate, of course, is 0. My other x-intercept looks to be about 2.5. So you're going to estimate if it's not exactly on a number, on a whole number. Okay? So here I have approximately 2.5. So that's what I'm going to note. And I'm also going to note that once again, my y coordinate at this place is 0. The next key feature I want you to take note of is the y-intercept. That is the place where the graph crosses the y-axis. And that is right here. So here, on the y-axis, the value of x is 0. So I want you to write these as an ordered pair. Once again, the purpose is to get you used to the fact and really, really know that at anywhere on the y-axis, the value of x is 0. So you would write 0, 2. Okay? Next important point I want you to take note of. I want you to take note of the vertex. The vertex of a parabola is the place where it's the turning point of the graph. It's a place where the graph changes. In this case, this part of the graph is increasing as x is getting bigger, so is y. And at the vertex, then the direction changes, right? The graph turns, and as x is getting larger, y is getting smaller. So it's decreasing. So that is the vertex, and the point is x is 1 and y is +4. So you're going to note that as an ordered pair. Now, the point of extremum is your vertex. Okay? On a parabola, it is either the high point, if it's a downward facing parabola like this one is, or it's a low point, a minimum, if it is an upward facing parabola. So in this case, here's my max, okay? So I'm going to circle max, and they only want the y value, alrighty? The max is actually, the x tells you where the max is, but the y coordinate tells you what the maximum is. So you only want to write 4, okay? The axis of symmetry is an x value, all right? So you only want to write the 1, all right? Remember, the axis of symmetry is the x coordinate of the vertex, and the max or min, depending on what it is the y coordinate of the vertex, all right? Now, these three words here, roots, solutions, and zeros, some people say that they mean the same thing. Sometimes they do mean the same thing. Sometimes they do not. Okay? So we're not going to get into the subtle differences between all three of these at this time. I just want you to pay attention to the fact that what you would put here is if you have x-intercepts, okay? If you have x-intercepts, that's what goes here. If you don't have x-intercepts, and I'm going to show you what I mean by that in just a second. So if you have x-intercepts, if your graph crosses the x-axis, then you're going to write these 2 points in these blanks, okay? Because the solution of a quadratic happens to be the place where y equals 0, okay? Which can be known as a zero of a function or a root, okay? Now, what I want to tell you in particular right now is that you have a couple of parabolas that go like this. They do not cross the x-axis. Do you see that? This parabola has a minimum that is above the x-axis. You also might have one that looks like this. Okay, once again, it's got a maximum that is below the x-axis. Those are special parabolas. We do learn about them, okay? But they don't have x-intercepts, so you could just say not applicable, NA, or don't have any, or something like that. And in that case, for one of these floating parabolas, what you're going to write here is complex. Okay? Complex numbers. That's what I want you to write. And that's it. So, thank you for paying attention. Thank you for engaging in this activity and doing your best with it.